So let's take a look at the last set of reactions for alcohols. What we're going to look at is that we're going to look at oxidation. So oxidation, a couple of definitions for that. It means you're adding oxygen. For us, a better definition is I'm forming more carbon-oxygen bonds. So you may form a carbon-oxygen double bond. That's more bonds. Carbon bond to two other oxygens, etc. So I have more carbon-oxygen bonds. A couple of things. Let's take a look at this. This is where the classification of alcohols becomes important because this oxidation works with primary and secondary alcohol. So it's got to be a primary or secondary alcohol. For tertiary alcohols, this thing is not going to work. And then we'll look in a second why this is going to be the case. So let's take a look at A here. So this right here, I'm looking at this carbon right here. That's going to be a primary alcohol. And what basically happens, I put oxygen in brackets for this. That means it can be any type of oxidizing agent. We don't have to worry about it for us, but it could be something like potassium permanganate, dichromic acid, something like that. Basically, what happens with this, I lose this hydrogen. And I lose one of the hydrogens by directly to that primary carbon. So when that happens, so I got this. And so what's going to happen is that carbon is going to form a double bond with this. I can rewrite this. Looks like this. I just move that hydrogen over to the other side. This right here, notice I form more carbon, double bond, oxygen here. That's what I mean by oxidation. I form more carbon-oxygen bonds. Couple things about this one. This type of compound is called an aldehyde. Now, one thing about this, these aldehydes get oxidized further. And so what's going to happen is I'm going to form what they call carboxylic acid. I'll lose this hydrogen right here. I'm going to form this. So basically, this aldehyde is an intermediate step. Almost always oxidize further into carboxylic acids. There is a way to stop it at the aldehyde, but for the most part, it goes to form carboxylic acid. Again, I have another carbon-oxygen bond right there. So for oxidation of primary alcohols, I get the aldehyde. Again, I rewrote it. I get the aldehyde, and then it oxidizes further now into the carboxylic acid. Let's look at the secondary alcohol. So I'm looking at this one right here. This is going to be a secondary alcohol. It's bonded to two other carbons. And again, it works basically the same way. I lose this hydrogen, and I lose that hydrogen. So I lose a hydrogen on the OH, and then I lose one of the hydrogens. In this case, just one of these hydrogen bond directly to that secondary carbon. So when that happens, I have 3 bonds to carbon. It wants to form 4, so it forms a double bond with the oxygen. This type of compound is called a ketone, and then it doesn't get oxidized further. It just stays at the ketone. So the primary will go to the carboxylic acid. The secondary, so again, this is a secondary, will go just to the ketone. Let's take a look at a tertiary alcohol. So a tertiary alcohol, so look at this carbon right there, bonded to 3 other carbons and an OH. In this case, this one won't undergo oxidation. So no reaction. And the reason is basically I got a hydrogen off the oxygen I can lose. But then this carbon right here, again, this is a tertiary. This tertiary one doesn't have any hydrogens to lose, and so nothing's going to happen. So for this case, for a tertiary alcohol, we're going to have no reaction. Let's take a look at these two reactions, try to see if we can predict the products right here. Again, the best way of doing this is to kind of classify as a primary, secondary, or tertiary before you get started. So I'm looking at this top one right here. So in this case now, I'm looking at this carbon right here, carbon number 1. For cyclic ones, you may have to add hydrogens or put the hydrogen in there to make it clear to you. So carbon number 1, it's bonded to, let's label these anyway, 1, 2, 3, 4, 5. It's bonded to carbon number 5, carbon number 2. So I know it's a secondary alcohol. Now notice that it's one bond goes to OH, so it has a hydrogen here. So even though we don't put the hydrogen there, there is a hydrogen there, and so it's going to undergo oxidation. It loses this, it loses that, so it's going to form a double bond with the oxygen. So basically, we form a ketone, and then we're set. So secondary alcohols form ketones. Let's look at this other one out here. This one right here now, let's kind of be careful now. Let's make sure we can count up and determine what type of alcohol it's going to be. So carbon number 1, 2, 3, 4, 5, and 6. Carbon number 1 is bonded to carbon number 6, carbon number 2, and it's bonded to this methyl group right here. So basically, this one right here, it has no hydrogens. This one right here now, it's a tertiary alcohol. So when it tries to undergo oxidation, it's going to be no reaction. Just to finish this up, let's do talk about thiols just quickly. So thiols can undergo oxidation, a little bit different than with the alcohol. So for instance now, say I have methane thiol. Say I have 2 of these. What's going to happen with this? I'm going to form what they call a disulfide bond. Link, actually. They call a disulfide link. You see these in proteins. So proteins are just amino acids linked together. Like your protein in hair, it's going to have this disulfide link. So it gives it a certain texture with it. So basically, I'm going to have something like this. So I'm going to have 2 sulfurs linked up together. So again, that's important in terms of proteins, etc. It's this disulfide link. Even in eggs, when you're cooking eggs, you're actually breaking apart the proteins in the egg. So you go from that watery egg to the white egg, etc.